Okay, so today we're going to talk about how we simplify expressions with 0 and negative exponents. And this is all part of the New York State Learning Standards AN4, which is learning how to use scientific notation and compute products and quotients of numbers in that form. Okay? All right, so as a way to develop the rule to try to figure out how we raise something to a 0 exponent, how we raise something to a negative exponent, I've written down some powers. So I've started with the powers of 4, and I started with 4 to the third power, which is 64, because that's 4 times 4 times 4. Okay, and 4 squared is 16, and 4 to the first power is 4. This we already know from the rules of exponents, and remember, exponents mean repeated multiplication. So in order to figure out what 4 to the 0 power is, let's think about the rule that we've established going down these powers. And I could have gone up higher. I could have gone 4 to the 4th and 4 to the 5th, but we can sort of see the rule just with 4 to the 3rd. All right, so every time we decrease the exponent by 1, so it goes from 3 to 1, we decrease the value of the power by 8, by a factor of 8. So 64 divided by 8 is 16. I'm sorry, not by 8, by 4. Okay, so 64 divided by 4 is 16. 16 divided by 4 is 4. Now, in order to keep that pattern, we have to think about, well, what's 4 divided by 4? Okay, that would be 1. So look what we've established right here. We've just established that 4 to the 0 power is 1. All right. Now, again, we could continue on with this pattern. We can divide what we arrived at for 4 to the 0 power by 4 in order to get 4 to the negative 1. So 1 divided by 4 is just the fraction 1/4. Okay, we could keep going here. 4 to the negative 2 would be 1/4 divided by 4. Okay, remember 1/4 divided by 4 is keep, change, flip. So keep, change, flip. So we keep the first fraction, we change the operation to multiplication, and we'd flip the second fraction, so that would become 1/4. So 1/4 divided by 4 is 1 over 16, rather. Okay, so 4 to the negative 2 is 1/16. But look what we're doing here. We're going from 64 to 16 to 4, and then we get 1. 4 to the 0 power is 1. Instead of, look at the rule that we've established between these two. 4 to the first power is 4. 4 to the negative first power is 1/4, right? 4 to the negative 2 power is 1 over 16, but 4 squared is 16. So if you think about the link between those two, and then the link between these two, you'll see that the rule that we're going to come up with in the second slide here will show you that, you know, if you can sort of at this point guess what 4 to the negative third power is, right? If you can already see sort of the rule is, you can start to see the pattern collecting here. So you can use that pattern to try to figure out what 4 to the negative third power is, right? So if 4 squared is equal to 16, but 4 to the negative 2 is equal to 1 over 16, and 4 to the third is 64, then you may already guess that 4 to the negative third is 1 over 64. Okay? Okay, and then let's look at what happens with fractions when we raise a fraction to a power. So I went ahead and written some powers of 2/3. So 2/3 to the third power would be 2 to the third power times 3 to the third power, which is 8 over 27. And 2 over 3 squared is equal to, remember we bring the exponent in, so it would be 2 squared over 3 squared, which is 4 divided by 9. 2/3 to the first power would just be 2/3. So in order to figure out what 2/3 to the 0 power is, let's look at the pattern we've established between these fractions. they're actually decreasing by the same factor every time. If I take 8 over 27 and I divide it by 2/3, that would be 8 over 27 times 3 over 2. Okay, and I would cancel these out, so that would be 1 and 4 there, so that would be, and actually I could cancel a factor of 3 out of here, so I'd have 1 over 9. I would get 4 over 9. So what I'm saying here is 8 over 27, if I divide that by 2/3, I would get 4 over 9. If I take 4 over 9 and I divide that by 2/3, I would get 2/3. And if I take 2/3 and I divide that by 2/3, I'm going to get the next power down. 2/3 divided by 2/3 is just 1. Okay? So you can see that, again, when I raised I took another number, different type of number this time than an integer. So I took a fraction and I raised it to the 0 power. And using the patterns of decreasing powers, I've established that 2/3 to the 0 power is 1. Now if I continue on with this pattern, if I take 1 and I divide it by 2/3, remember when we take a number, when we divide by fractions, we can keep, change, flip. So it's 1 times 3 over 2. Well, 1 times 3 over 2 is just 3 over 2. So 2/3 to the negative first power is just 3 over 2. Okay, so let's just see, let's put these things together here. If 2/3 to the first power is 2/3, but 2/3 raised to the negative first power is 3 over 2, look at the pattern that you're establishing here. Looks like you're just taking the reciprocal of the positive power. And that indeed is going to be our rule. Okay, so let's take these rules one at a time. The first rule that we established is that anything to the 0 power is 1. So anything raised to the 0 power is 1. Alternately, you could write it this way. But that's whenever x is not 0. So there's a strange things that happen when x is equal to, when 0 is raised to the 0 power, because it's sort of the intersection of two rules. So anything, we know that anything raised to 0 raised to any power is supposed to be 0, right? So all along here, these numbers should be 0. But anything to the 0 power is supposed to be 1. So all these numbers are supposed to be 1, whereas all these numbers are supposed to be 0. That makes this right here, 0 to the 0 power, an intersection of these two rules. And so what's it supposed to be? You know, is it supposed to be 1 or is it supposed to be 0? So we consider this to be undefined by the established rules that we have. Okay, so let's try a few of these problems here. Let's see. So 4 times x to the 0 power. So notice the difference between 1 and 2. The base for 1 is just x. The base for 2 is the quantity 4x. So since the base is for 0 is just x, this is equivalent to 4 times x to the 0 power. Just separating them with multiplication, a multiplication symbol. That would be 4 times, and this would be 1. Okay, 4 times 1 is 4. Now this is a little different because this is, the base here is 4x, so this is supposed to be just 1. Because anything raised to 0 power is 1, as long as x, the only thing that x can't be in this example is 0. In all of these examples, if you have an x, the base cannot be 0. Okay, or it would be undefined. Okay, here the base for the 0 power is, the 0 exponent is negative 5, so that's just 1. But 4 is different than 3 because the base here is not negative 5. The base to the 0 power is 5. So this is equivalent to saying negative 1 times 5 to the 0 power. Well, we're supposed to raise things to the exponent if we can before we multiply. So 5 to the 0 power is 1, so we have negative 1 times 1. That's just negative 1. Okay, notice how these two answers are different between 3 and 4. That's because 3 had parentheses indicating the base would be different. Here, you could put parentheses in, but, oops, really, if you put the parentheses in, it would just be negative 5 to the 0 power. Okay, or the opposite of 5 to the 0 power. Okay, now the next rule that we saw was the negative exponent rule. So remember when we took down the powers of 4, we arrived at the idea that in order to raise an integer to a negative exponent, we actually, these two rules are very similar. They're actually the same rule. The top rule is a specific case of the bottom rule. So if x is an integer, we make what we call a unit fraction. So we put 1 in the numerator, and we raise x to the positive exponent in the denominator, as long as x is not equal to 0. So for instance, if you had 2 to the negative 3, you would make a unit fraction. So you'd put 1 in the numerator, and you'd put 2 to the 3 in the denominator, and then if you can evaluate that. So 2 to the third is 1/8, is 8, so it's 2 to the negative 3 is 1/8. Okay, which is actually the reciprocal of, 2 to the third is 8, so 2 to the negative third are reciprocals of each other. 2 to the third and 2 to the negative third are reciprocals of each other. Now, a more general case for this rule is when you have a fraction. Remember, this, I say it's general because that x could be written as x over 1 to the negative n would just be the reciprocal of that, which is 1 over x to the n. And then you could draw that exponent in 1 to the n over x to the n. But 1 to the n is just 1. 1 to any power except 0 is just it's just 1. Right? And so I arrive at the same place that I had up here. But if you have another type of fraction that's not an integer, okay, so you have a proper fraction, so you have 1 over b raised to the negative exponent, you reciprocate the base. So if the base is a over b, then you get b over a, and you raise it to the positive exponent. Well, we know when we have exponents outside of fractions, if the whole fraction is raised to that exponent, not just the numerator or just the denominator, we can bring that exponent in. So really, this would be b to the n over a to the n. Okay, let's try a few practice problems here. If I have 5 to the negative 2, this would get me, so our rule is make a unit fraction and raise that to the positive exponent. So I have 1 over 25 here. Since I can evaluate 5 squared, that's 1 over 25. Okay, 7 to the negative first power. So remember, that would be a unit fraction. I put 7 to the positive first power in the denominator, and then I can evaluate that. That's 1 over 7 to the first power is 7. Okay, another way of looking at that is that 7 to the negative first power is going to be a reciprocal of 7 to the first power. 7 to the first power is 7, so the reciprocal of 7 is 1 over 7. Okay, now 1 over 3 to the negative second power. So here it's a little trickier because you're going to get a compound fraction. So just focus on the denominator for a minute. I have 1 over, well, 3 to the negative 2 power is the reciprocal of 3 squared. 3 squared is 9. So the reciprocal of that is 1/9. So 3 to the negative 2 power is 1/9. So that goes in the denominator of this fraction. So you have 1 divided by 1/9. Okay, so let's just figure out what that is. Let's write it out horizontally for a minute here. 1 divided by 1/9 is keep, change, flip 1 times, and then I flip 1/9 to get 9. Okay, so 1 divided by 1/9 is 9. So if you think about that, that's how many 1/9 parts are there in 1? And it makes sense that there are 9. So let's look at what we just arrived at here. We just figured out that 1 over 3 to the negative 2 is the same as 9. So in other words, 1 over 3 to the negative 2 is the same as 3 to the positive 2. Okay? Now, I have this whole fraction being raised to the negative 3 power, so if we remember the rule back here, if I have a fraction raised to a negative exponent, I reciprocate the fraction to the positive exponent. Okay, so let's see. Reciprocate the base, so if I have 5/4, it's going to be 4/5, and I'm going to raise it to the third power. Okay, and then the third goes on each the numerator and the denominator. Well, 4 to the third power is 64, and 5 to the third power is 125. Okay? Now, this one has a combination of rules. So if you remember, this is a power of a power. It's a power being raised to another power. So remember, we said that what we had to do here was multiply it. So I can just multiply the two exponents together. Negative 1 times positive 2 is negative 2. Okay, so this is equivalent to 4 raised to the negative 2 power. Okay, now remember there's two ways of thinking about this. You can write this as a unit fraction with a positive exponent in the denominator. So it gets 1 over 16. Or you can think of 4 to the negative 2 as being the reciprocal of 4 squared. 4 squared is 16, so the reciprocal of that is 1 over 16. Okay? Okay, same thing here. We have a power over power. So I'm going to do the same thing here. Negative 3 times negative 2 is equal to positive 6. Okay, so instead of having 8 to the negative 3 raised to the negative 2, I just have 8 raised to the 6th power. Actually, I'm going to leave it right there because that number is going to get too large if I try to evaluate it. All right, and finally for number 7, this is our last example. All right, since we have each the base of 3, we can use our product of power rules, which means that we can add the exponents together. Negative 2 plus negative 5 is equal to negative 7. Notice we're using all of our skills here. We're adding integers. We're using the product of power rules in order to evaluate these negative exponents. So we keep the base and we rewrite the added exponents together. So this ends up being 3, so you have 3 to the negative 7th power. So you can think of this as 1 over 3 to the 7th power, and that's as far as you want to go with that because 3 to the 7th power actually gets pretty large. Okay, and that's the end of the lesson today. So what you are responsible for is being able to, for instance, rewrite this in terms of, usually what you're asked to do is you're asked to, you're given something with a negative exponent and you're asked to write it with a positive exponent. So, for instance, someone might ask you to rewrite this expression with a positive exponent. So you'd have to, notice you can't, your base is x, so you can't, they'd have to put some sort of qualifier on it, so they'd have to say that first. So you might be asked, okay, write this with a positive exponent. So you're going to have to understand the rules that this is, if this were an integer, I would put this as a unit fraction with a positive exponent, and you would just rewrite it that way. Okay, or similarly, you might be asked to write, something like this with a positive exponent. And you'd have to know, well, the rule for fractions is you reciprocate the base. Oops, that's an n on the bottom there. You reciprocate the base, so you would have n over m, and you'd raise that to the positive 3rd power. Okay, now, and right here you can use the power rule to bring the power into each numerator and denominator. All right, and then that would be the same. That would be what you want to do there. That's a typical thing that you might be asked to do in an integrated algebra exam. Okay, so that's the end of the lesson. You're just going to practice what you've learned in this lesson on problem set 7.